All right, guys, this is going to be the second video here on 9.2, looking at significance tests for proportions. And then the 9.3 video, we'll look at significance tests for means. And so, yeah, let's get into it. So first thing, we've talked about proportions quite a bit. I'm just going to, again, highlight it a little bit. So proportion, this tells you the type of problem that we're dealing with. And so here, we're looking at percentages. So whenever you see a proportion type of problem, you're going to be looking at percentages. So that kind of gives you a hint as to what you need to be doing. And so what are the three conditions we need to check? So first one is random. Second one, n has to be less than or equal to 1/10 of big N. Number three, n times p has to be greater than 10. And n times 1 minus p also needs to be greater than 10. Okay, so all the same conditions that we've used before. And again, we're assuming that HO is always true. It's the whole guilty until proven, or innocent until proven guilty idea. But again, we need to check these conditions. The randomization one allows you to extrapolate to the population. The third one allows you to check for normality. The second one here is your independence check. So good little reminder in those. So what is a test statistic? This measures how far sample statistic diverges from what we would expect if the null hypothesis HO were true in standard units. Think z-scores, right? Z-score is a form of standard units. So your test statistic is equal to your statistic minus your parameter divided by the standard deviation of the statistic. And so this whole process here of subtracting the mean divided by the standard deviation is called standardization. So what is the test statistic for proportions? And is this on the formula sheet? So here we're going to have z equals p hat minus p over the square root of p times 1 minus p over n. Okay. And just to note, this is not on the formula sheet. All right, so now this leads into the state plan to conclude. All right, so what is the state plan to conclude for this? So your state is going to be to what hypothesis do you want to test, and what alpha. Okay, define your parameters. Your plan is going to be to choose the appropriate method and check conditions. You do is perform calculations. You're going to compute test stats and find p-values. And then your conclusion make a decision about the hypothesis. And again, context is the key. Okay, so now what happens when the evidence doesn't support HA at all? You say is there's no need to continue with the significance test. The conclusion is clear. We fail to reject HO. And again, context. right? So that leads into the next problem. So here, we're looking at the way people, if they prefer to kiss or not. And so here I can write a couple things. I can say HO is that P is equal to 0.5. And we're talking about in this problem if we're leaning one direction or not, and if they prefer a certain way. So we're going to say P is greater than 0.5 if they prefer something. Right? If they don't prefer it, it'd be equal to 0.5. And then in our sample, we find that P hat was 83 out of 124. 83 out of 124, which is equal to 0.67. Okay. And so then when we want to compute our Z, this is just from the equation from before. This will give you a good example, so then you can try the next problem on your own. 0.67, right? That's what we use, minus the parameter, which is 0.50, divided by the square root of P times Q, so 0.5 times 0.5 all over N, which is 124. Okay. Once you calculate that, you can then find a p-value from there. Okay, so that's just using the equation from before. So now take a couple minutes, see if you can figure it out for this problem down below. Okay, see if you can figure it out. See if you can do a state plan, do conclude. We've done a couple of this points to see if you can figure that out. But again, we will go over it together in class. So at least the next part, can you use confidence intervals to decide between hypothesis tests? So yes, there is a link between the two. Between confidence intervals and two-sided tests. The 95% CI is an approximate set of p-values or p's that would not be rejected by a two-sided test at alpha equals 0.05. Okay. And so the thing is that CIs give you more information, but CIs only work for two-sided tests. So if you think about it, that kind of makes sense, because if we're doing a two-sided test, okay, if we want a 95% confidence interval and a two-sided test, your 95% confidence interval, which would be this is your 95% here. Okay, and then our this is your fail to reject region in the middle. So FTR, fail to reject. And then what parts are on the outside? This is your rejection region here, right? And then here's your alpha in these lines. And so when you find the 95% confidence interval, this is the part in the middle. So then you can kind of make some conclusions about what happens with the outside. That's kind of the idea with this. So here, a confidence interval gives you a range from 0.180 to 0.274. Okay, and this is based on a previous problem where it said that we know that P is supposed to be 0.31. And so here we can say yes, the confidence interval gives us evidence. Gives a range of plausible values for P, since P, and that's 0.31, is not in the range of plausible values, we should consider some further investigation. We have evidence against HO. Last couple of things. in this video. So now we're going to talk about power. What is power? How do you calculate power? So power, give you the definition first, and I'll give you a little equation. So the power of the test against a specific alternative is the probability that the test will reject HO at an alpha level when the HA value of that parameter is true. Think this is the likelihood of avoiding a type 2 error. Okay. And so then we can give you the equation. So power is equal to 1 minus beta, right? Where beta is your type 2 error. So then if you want to try to avoid it, you're just going to use 1 minus beta. Okay. More type 1, type 2, practice in this problem here. So take a second to try that and see if you can try think about the description for power. And again, we'll talk about those in class. Okay, now a couple of things. What can you do to increase power? You can increase the sample size. Increase the alpha. Okay. You can also increase the difference between HO and HA. So think more extreme. And account for more variability. So this is another way of saying is improve sampling. All right, scrolling down here. What is the correct decision? So again, try this on your own, see what you come up with. Try to find the Z and the try to find the Z score, look at the probabilities for good practice there. We'll kind of look at the rest of this problem in class as we look at different alphas and betas and the different different outcomes and what is going to happen. Okay. So we'll look at this problem in class, and then that'll be it. So that's it for the 9.2 video. As always, if you guys have questions, please let me know, and we'll go through over the examples that we skipped in this video in class. All right, have a good day.